Welcome to
Family Math number 46.
not Family Math 46, Math Problem 46. Yeah, Family Math was yesterday. Okay, so this is getting back to our primes.
Yeah.
So we have a fun problem that's based on one. Harder problem solving had a harder one than this, so I made it slightly easier. So if the number 5,400 equals 2 to the x, some power of x, times 3 to some power of y, times 5 to some power of z, what are x, y, and z?
Ooh.
Okay? So we have to factor 5,400.
Well, we know we can factor into all of these because the divisibility will fit all of them.
Yeah, the divisibility works for all of them. So, well, how do you think we should solve a problem like this? What should we do?
We could try some powers.
Okay, we could try some powers and see if they work. That'd be one thing. That's kind of a hard way to do it. What would you do if I just said factor 5,400? What would you do?
Well, you could look at some divisibility rules.
Yeah, you could look at the numbers that go into it. You can make your factor tree. So start with 5,400.
5,000.
Ooh, your marker's getting a little out of gas here. Maybe this one will work better. 5,400. Okay, now, what are two easy numbers that you can see that multiply together to be 5,400? What's an easy way to factor this first to get some smaller numbers?
Well, you could just maybe try to split it in half.
Okay, splitting it in half would work, definitely, but that would still leave you a number that was in the thousands here. So we're trying to see if we can see two numbers that are kind of big numbers that multiply together to be 5,400.
Well, since we know that all of these go into it, maybe we can multiply them together and kind of see what they equal.
Well, but that's what we're trying to figure out. So don't worry about this part. I think that part's confusing you a little bit. Let's just try to factor 5,400.
We could try to factor 5,000 and then 400 and add them together.
Well, that doesn't work, unfortunately, because like if I was going to factor 6 and 4, those add up to 10, right?
Yeah.
6 is 2 times 3, 4 is 2 times 2, but 10 is 2 times 5. So I don't have any 5s in here, right?
Yeah.
Yeah, so that unfortunately doesn't work. Just grab an eraser there. Thanks. Okay. What's nice and easy about the number 5,400?
It's even.
It is even, yep. Anything else nice and easy about it?
It ends in a 0, so we know if that is divisible by 54, maybe we could add a certain number of zeros to it.
Ah, very good. See, how many zeros does it end in?
It ends in 2 zeros.
So that means it's 54 times what?
54 times 100.
54 times 100. Now we're into some things that are much easier to factor.
And now,
So what's 54? Can we factor 54?
well, it's 27. Well, what's 54?
What does 54 factor?
It's 2 times 27.
2 times 27. Hey, there's a prime.
Yay!
How does 27 factor?
It's 3 times 9.
3 times 9. Hey, there's a prime.
And now 9 is 3 times 3.
Hey.
But we've still got another branch.
Yeah, we got this branch over here. How does 100 factor?
It's 2 times 50.
2 times 50.
And which 50 is 2 times 25. And let's see, is 25 prime? It's 5 times 5. It's 5 squared, which is 5 times 5.
Hi, 5. 5 times 5.
And those are both prime.
Those are both prime. Now, how many 2's do I have in my really complicated tree
You
here?
have 3 2's.
So this is 2
Cubed.
cubed. So I'll cross those out so we don't get confused by them. How many 3's do I have?
It's 3, so 3 cubed times 5 squared.
Aha, so this is equal to 5,400.
Cool.
Cool, so what did x equal?
X equaled 3.
What did y equal?
Y equaled 3.
And z equaled?
2.
All right, hey, cool. So they told us it factored into 2s, 3s, and 5s. All we had to do was factor it, find out what it was, and then the easy first step. If you just start dividing by 2 at this stage, you're going to get some complicated numbers.
Yeah.
But one important thing to notice is, hey, wait a minute, this is really easy. This is 54 times 100. So why don't I just factor 54 and factor 100? Because those two things times each other make 5,400.
Yeah. It's cool, yeah.
Pretty cool. All right. Good job, honey. Good job.